Hi my music friends, thanks for watching Harmony Hub. In this video, I will talk about the inversion of intervals. How do we invert an interval? To do that, we put the bottom node of an interval above the top node or the top node below the bottom node. For example, we are given A and C. This is how we can invert it. We can put the bottom node above the C, or we can put the C below the A. One more example. To invert these two nodes, you can do this. This is a top node which becomes the bottom node now, because we will put the C above D. Or we can do this. C is the bottom node. Now it becomes the top node because we put the D below the C. So first instance, C goes up. Second instance, D goes down. When an interval is inverted, two things will change: the numerical value and the modifier of that specific interval. When we invert a unison, it becomes an octave. When we invert a second, it becomes a seventh. When we invert a third, it becomes a sixth, a fourth to fifth, fifth to fourth, a sixth to a third, a seventh to a second. Please notice that the numerical values of the original interval and the inverted interval always add up to 9. 1 plus 8 equals 9, 2 plus 7 equals 9, and so forth. For the modifier, when we invert a major interval, it becomes a minor interval. A minor interval becomes a major interval. A diminished interval becomes an augmented interval. An augmented interval becomes a diminished interval. The only exception is the perfect intervals. When we invert a perfect interval, it will also be another perfect interval. Show you some example. We are given G and B. G and B is a major third. We're going to invert G and B. I'm going to put G above the B. So according to this principle, a major interval becomes a minor interval. A third becomes a sixth. So when we invert a major third, it becomes a minor sixth. For this instance, I put the G on top of the B, but I can do the other way around. G here, I'm going to put the B below G. This is also a minor sixth. One more example. B flat and C. B flat and C is a major second. If we invert it, I'm going to put the B flat above C. According to the principles on the previous slide, major becomes minor, 2 becomes 7. So when we invert a major second, it becomes a minor seventh. We can do it the other way around by having B flat here and the C below B flat. We will still get the same result, a minor seventh. Why do we invert intervals? And this is why. We invert smaller intervals, the unisons, the seconds, the thirds, and the fourth, to get their corresponding intervals. The fifth, the sixth, the seventh, and the octaves. We do that because we want to avoid counting so many half steps or whole steps to get the large intervals we want. Instead, we invert an interval with a small numerical value to get its corresponding inverted interval. Let's say if we were to build a major seventh, we have to find out the major seventh above B. So a major seventh consists of 11 half steps. There's a lot of half steps to count, so we might make mistakes in the process. So what do? Major seventh is what we want to get. We're just going to put it down here. And when we invert a major seventh, we know that we will get this, a minor second. So instead of counting up, we will count it down by a minor second. A minor second only consists of a half step. So B and A sharp is a minor second. Now how do we get the major seventh? We invert it. We invert the minor second to get the major seventh. B, I'm going to get the A sharp above B. So this is a major seventh. Okay, I don't have to count 11 half steps to get to that result. Okay, let's do another one. If you're given an A, we're going to count it down from A to get a major 6. Well, a major 6 consists of 9 half steps. There's a lot of steps to count, but when we invert it, we know we will get this. A minor third, major becomes minor, a 6 becomes a third. So this we need to count it down, but we can invert it, so we will count it up, a minor third. A minor third only consists of 3 half steps. A to C is a third. Now we have to make sure there is 3 half steps in between A and C. A to A sharp to B, B to C. So from A to C is a minor third. When we invert it, we'll put the C below A. And now we have a major 6. Well, if you want to make sure, you can do an experiment, you can double check. From A to C is a 6. Now if you count it down, if there are 9 steps, then this is a major 6, right? This is a very tedious process. That's why we invert the minor third to get the major 6. But just to prove a point, I'm going to count from A to C, the half steps in between them. A to G sharp, there's 1 half step. G sharp to G natural, G to F sharp, F natural, F to E to E flat or D sharp to D natural to D flat to C. There are 9 half steps, so this is correct. So you can see how tedious the process is if we don't invert it, especially when we are dealing with intervals with higher numbers. It's usually the 6th or the 7th, so we will invert the corresponding seconds and thirds to get to the corresponding larger intervals, which will make our life easier. After all, what we are dealing with is just a few intervals, right? Instead of so many intervals. If we invert a perfect unison, we get a perfect octave. We invert a minor second, we get a major 7th. When we invert a major second, we get a minor 7th. When we invert a minor third, we get a major 6th. When we invert a major third, we get a minor 6th. When we invert a perfect 4th, we get a perfect 5th. These are all of the intervals that we need, from perfect unison all the way to perfect octave. So we have perfect unison minor 2nd, major 2nd, minor 3rd, major 3rd, perfect 4th. And then if we invert all of these low number intervals, we'll get to their corresponding intervals. So perfect 5th, minor 6th, major 6th, minor 7th, major 7th, and perfect octave. We only need to know these 6 intervals. So all of the intervals now have been reduced to just 6 intervals. So it's easier for us to memorize and remember. It makes our life more efficient. Thank you so much for watching Harmony Hub, and I will see you next time.